Yo, what's up? If you're watching this video, missed when we first started talking about implicit differentiation, and maybe you've been lost till last week. So, here is kind of the catch up breakdown of what implicit differentiation means. The first thing we did was this number two, so you're realizing that I'm lying. This was the second thing we did. But the first kind of like hard, useful thing we did was we found the equations of the lines tangent to y squared equals x when x equals 1. You might notice that this is not a function, right? When we graph this, it looks like this. Y squared equals x looks like this. A lot of people that did this broke this into two different functions, right? Said that this top part can be represented by y is the square root of x, and this bottom part can be represented by y equals the negative square root of x, and then treated it like two problems, right? They said, oh, at x equals 1, our point is 1, 1, or 1, negative 1. 1, 1, or 1, negative 1. We said, okay, the first one will be this. The second one will be this, and we just need to find our slopes. So you can find your slope here, plug in one, Bob's your uncle. Fine. This is kind of like the classic, we know how to take the derivatives when we have y equals blah, 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 a bunch of x stuff. However, I want to have a new method because in the future, we're going to get relationships such as this one, where we can't solve for y. Right? Where our plan of, oh, well, I'll just solve for y. I might have to break it into a piecewise function. I might have to break it into like a multi-part relationship. Fine. That might not be an option in the future. So I want to develop a plan for what happens if we have x's and y's in a relation and I either can't solve for just y or don't want to. So here's that plan. Here's my new plan. If I've got y squared equals x, and I am taking the derivative with respect to x of this relationship. That means x is my independent variable, is the thing I'm plugging in, and y is the thing I'm getting out. Y is the dependent variable. We can think of that as like, so basically y is a function of x, which means when we're taking the derivative of y squared, if it's a function of x, we should use the chain rule. Right? The chain rule is when we have a function, y, inside of another function, something squared. So I think when we take this derivative, I'm going to get 2 times y, because that's the derivative of the outside. And then I'm going to multiply it times y prime, because that's the derivative of y, which is the inside function here. Right? It's not just an x, so we have to treat it differently than just x. And the way we treat it differently is we do the chain rule every time we take derivatives with something with respect to y. Now, I've taken my derivative. I can solve for y prime using, math 1 and math 2 skills. And I say, okay, the derivative at any point of y squared equals x is 1 over 2 times y. So when x equals 1, that means y equals either 1 or negative 1, as we figured out here. So the slope at 1, 1 and the slope at 1, negative 1 will be 1/2 and negative 1/2. And then we can go on and find our tangent line from there. Cool. Next one. If I want to find the derivative dy dx of this function, that means I'm treating x as my independent variable, y as my dependent variable, and I'm taking the derivative of every term. All right, I do the easy ones first. So x squared becomes 2x, 10 becomes 0, right? Because the derivative of a constant is nothing. Y cubed is my next easiest one. I get 3 times y prime. The 3y squared, sorry. The 3y squared coming from the power rule and then the y prime coming from the quotient rule. And then this, I've got to use the product rule for. So I copy down my first function and multiply times the derivative of y, which is y prime. And then I copy down my next function and multiply times the derivative of negative 2x, which is negative 2. I'm not quite finished. Usually this is when we put a box around things and we're done. But what I want to do is I actually want to solve for y prime. So here's y prime. Here's y prime. The way I solve for this is I rewrite all of the terms with y prime in them on one side of the equation. I move all of the terms that don't have y prime to the other side of the equation. So I moved this over and I moved this over. I kept this and I kept this. Now I'm going to factor out a y prime, leaving behind 3y squared and negative 2x. And then I'll divide both sides by what I'm multiplying y prime by to get it totally alone. This is 3y squared minus 2x. That's the derivative. Because we're doing implicit derivatives rather than explicit, our answers will probably have both x's and y's in them. That's kind of the difference. This one had only y's, but that's kind of special. All right. Last one I'm going to do. Actually, I'm not going to sketch it. I'm just going to find it. In order to find the tangent line, I know I need to do y minus 9/4 equals slope x plus 5, because they gave me a point, and I've got point slope form. Yep. Now I need right here kind of the derivative. So I need y prime at this point. So we'll find the equation for y prime, and then we'll plug in this x and this y to find our actual number. Let's do it. We've got, this is my function. That's a y. And I'm going to write the denominator constant as just a total constant so I can see the power rule better. When I do the power rule here, I get 2/16 x minus 2/9 y times y prime, because every time we take derivatives of y with respect to x, we have to use the chain rule. And then the derivative of 1 is 0. Now, because I'm solving for y prime, I want to get all the stuff with y prime on one side of the equation and all the stuff without it on the other side. So I'll put it over here. Now I will multiply by 9 over 2y on both sides, because the 9 will cancel, the 2 will cancel, and the y will cancel, leaving me with only y prime on this side. Over here, the 2's cancel. I'm left with 9x over 16y. I want it at negative 5/9/4 though, so I have 9 times x over 16 times y. The 9's cancel. 16 divided by 4 is 4, which means the slope of our tangent line is negative 5/4. This is the plan for implicit differentiation. If you have questions still, that makes a lot of sense to me. So give this video a watch, try to follow along, and then come with me with more specific questions. I think that's where we're at now. Sounds good?